we're up to the last step before integration. We're working on optimization today. Optimization is just trying to find the ideal value, normally finding a max or min, and we're going to need to find two different equations, one being the primary, which we want to optimize, and the secondary equation, which will be used to help us simplify the equation. So, what we're going to do here, number one on your worksheet says a fence is formed by a rectangle and equilateral triangles, with the bases being on the ends of the rectangle. The perimeter of it is 1,000 feet. We want to find the dimensions so that the area of the rectangle is a maximum. Well, let's start with that. The area of a rectangle is the maximum. Well, the area of this rectangle, if I set it up this way, will be x times y. That's what I want to maximize. That's what I want to optimize. So I'm going to say f of x equals x times y. However, this isn't f of x. We have another variable in here. So we need to say, well, do I have another formula I can use, another equation that can help me get rid of that y? Well, the other equation is based on the perimeter. It says the perimeter of this is 1,000 feet. And what is the perimeter in terms of the x's and y's? Well, I have 1, 2, 3, 4 x's on the outside and 2 y's also on the outside. 4x plus 2y. What I want to do is take that and solve it for y. So that would mean that I have 1,000 minus 4x equals 2y, divided by 2. So 500 minus 2x is equal to y. What I'm going to do is take this for y and plug it into that equation. So now my f of x will equal x times y, or x times this equation, 500 minus 2x. From there, can I simplify it? Yes, make it 500x minus 2x squared. That looks a lot nicer. And at this point, if I want to find a maximum or a minimum, I'm going to take a derivative. So, when I take the derivative, f prime of x will be 500 minus 4x. To find a max or min, I want to set that equal to 0. So that means I'll have 500 is equal to 4x, or that means that my answer for x should be 125 feet, assuming this was in feet. Now, we got to find what y is. How do I do that? Well, I, again, just go and plug it back in to the equation that I knew. So, to find that, 1,000 equals 4 times 125 plus 2y. So 1,000 should equal 500 plus 2y. So you should get in the end y is equal to 250 feet. So that's how you do that optimization problem. Let me give you one other problem to look at. Number 5 on your sheet was the sum of two numbers is 298. The product is a maximum. So I'm going to say my two numbers are x and y. Their sum is 298. So x plus y equals 298. Their product is a maximum. The product will be x times y. That's what we want to maximize. That's what we'll call f of x. Let's get this first equation, the secondary one, by itself. That means that y will equal 298 minus x. So now I can go and plug that in to my primary equation right here. And now say that f of x equals x times 298 minus x. Again, can I simplify that? Definitely I can. F of x equals 298x minus x squared. Now it's time to take our derivative. So f prime of x will equal 298 minus 2x. I want to set it equal to 0 to find the maximum. 2x equals 298. That means x equals 149. Plug that back in my original equation. That means I'm going to get y also is equal to 149. And this is pretty normal to see you have two answers for x and y that are the same, especially like with the rectangles. You'll have the most area when a rectangle actually is a perfect square, so the two sides are the exact same. Same here with the numbers. You're going to have the biggest product when you have the numbers being exactly the same when you're squaring it, other than something like 148 and 150, for example. So something to keep your eye on as you're doing problems. You should see a lot of times you'll get perfect squares or the numbers being the exact same for your answers.